الحمد لله رب العالمين والصلاة والسلام على رسول الله سيدنا محمد وعلى آله وصحبه وسلم أجمعين. أما بعد، اللهم علمنا ما ينفعنا وعلمتنا إنك أنت العليم الحكيم. So we continue in this section 14.7. What remained is only the last part, which is the optimization problems. So let's remind ourselves what we took in that section. We said that there is a local minimum and maximum values of the function, and there is an absolute maximum minimum of a function of 2 or 3 variables. In order to find the maximum minimum values, we look for what we call the critical points of the function, and the critical points are the points in the domain of the function, and such that the first partial derivative is equal to 0, both of them, and or where the derivative does not exist. And the definition is a function f is said to have a saddle point on a critical point if every open disk center f is neither local minimum or local maximum at that point. And this is an example of one of these. We solved many examples on this, and then we had what you call the second derivative test. This is a very, very useful test. You look for the critical points where the first partial derivative is equal to 0, and then you substitute in this discriminant. Okay, so if the d is greater than 0 and the second derivative xx is greater than 0, then we call it local minimum. If d is greater than 0 and the second derivative less than 0, then we call it local maximum. If it is the d, the discriminant, less than 0, automatically we will say the point AB is a saddle point. If d equals 0, Allahu Alam, we don't know what's going on. You have to think of something else. And an easy way to remember the d is this way, okay, or you can memorize it. I think it's simple. You can remember it. So this is called discriminant or coefficient of the function f. And then we solved one of two examples related to this one. I believe we solved all of these. And then we talked about the absolute maximum minimum values on a closed and bounded domains. Okay, so if you have a closed set of bounded set, we learn how to do that also. So we need to find the values of function on the critical points inside D, and then find the extreme values of f on the boundary of D, and then look for the largest and smallest value of this. We solve these things here. Okay, we solve all of these examples, and we stopped at here. Last time we stopped at here at the optimization problem. As an application of the maximum minimum values, we are able to solve some of what we call the optimization problem. Optimization problem is a problem that you will look for the largest, the biggest, or the smallest, the lowest quantity of such a thing. Okay, so for example, in this example, we say find 3 positive numbers whose sum is 12 and the sum of whose squares is as small as possible. So he asking for the smallest of the sum. In the same time, there is an information about the sum of these numbers here. So let's start solving this one here. Okay, let's solve this problem here. Okay, Bismillah. So we are looking for three numbers. Actually, in the question he said 3 positive numbers. Okay, but to find the 3 positive numbers, Shabab, call them. Okay, and numbers, let's say they are different. So call them x, y, z. Okay, so these are the numbers. Number x, number y, or a, b, c if you want. Let's call them as variables. طيب يا شباب. Now, what equation should I write? He said, whose sum is 12? Whose sum is 12, meaning that x plus y plus z is equal to 12. So this is one equation related to this. And the sum of whose square is as small as possible. So the sum of their squares is like this, x squared plus y squared plus z squared. But he said, I need this the smallest as you can. So this meaning that, Shabab, I'm looking for the minimum of this quantity. So this quantity, let's call it f. Let's call it a function f equal these guys here. Okay. Now this is a function of three variables, x, y, z. But I have another information here, x plus y plus z equal to 12. So I can't get rid of the z from this equation here, right? So here z is equal to 12 minus x minus y. Okay. So this implies that f, now this is a function of x and y, equal x squared plus y squared. Now plus, I can take this z and put these guys here, which is 12 minus x minus y all square. Okay. So now this is became a function of two variables. We are looking for the minimum value of this function. Okay. So this is what we are doing here. What we are finding the minimum of this function here. طيب, how to find the minimum of this function here, Shabab? I have to look for the critical points. The critical points meaning that you need to find the derivative f with respect to x. But it's better to open this. It's better to open this, okay? So f of n x or y equal x squared plus y squared plus, now if you open these, this is 144 minus, and then you're going to say 2 times first times second. يعني think of these يا شباب as second. هذه يعتبرها كأنها second. ها تقول 2 في 12 24 في هذه، فمعناته 24x minus 24y plus x plus y all square. So we can think of it this way. Now from here يا شباب, this is x squared plus 2xy plus y squared, right? So we can add to these. So we have 2x squared plus 2y squared. And this pen is not good anymore, so we choose another one. And then you're gonna have plus 2xy. And then خلاص, we are done with these. Now I plot those guys. Plus 144. So now this is a function f. This is the function f. Okay. طيب. Now we find the critical points. Okay. Now we find the critical points. So what are the critical points, يا شباب? Okay. So let me maximize this. يا شباب, you're gonna have exam this Wednesday. So we take fx, fy, the derivative with respect to x and derivative with respect to y. So derivative with respect to x, so we get 4x, and then here we get plus 2y, then minus 24, and we are done. Now derivative with respect to y, so we get 4y, and then plus 2x, and then here minus 24. And remember that I make them equal to 0. So I have to solve these equations. Okay. طيب يا شباب, how to solve these equations? This system of equations. Meaning that for x, you can divide by 2, by the way, ya شباب. You can divide by 2, so you get 2x plus y equal 24, and 2y plus x equal 24. So now we have this system of equation.
Equal 12.
Okay, 12, yes, 12. 12, yeah. Yes, very good. So how to solve these equations, ya شباب? Yes, Rakan. Call this equation 1. Call this equation 2. Yes, Rakan, تفضل.
To make x the same, so we can get rid of x, what we multiply by 2. The down.
Multiply this by 2 and subtract.
Yes.
You can think of, or substitute x equal 12 minus 2y here.
Yes, yes.
So you have to both ways. So if you say 2 times equation 1 minus equation 2, this will give us, so if I multiply this by 2 and subtract it from the below, the 2y will cancel with 2y, right? Then 4x minus x will becomes 3x. خلاص طيب. سلام. 4x minus x we get 3x, 2y minus 2y will go, 24 minus 12 becomes 12, right? So what is x يا شباب in this case? X is equal 4. طيب substitute x equal 4 in let's say in equation 2. What you will get? 2y plus 4 equal 12. So 2y equal 8. So this implies that y equals 4 also. Right, now we have x equal 4, y equal 4. The third number, how I can get the third number, شباب? The third number comes from, can anyone point it out?
substitute.
محمد ايه اللي هو هذا اللي from here. Very good. So z equal 12 minus 4 minus 4. So this is 12 minus 8, which is 4. طيب يا شباب. What we found only one critical point. About z, leave it later. Now, x equal 4, y equal 4. This is a point. This is a point of the function f. Okay. The point 4, 4, 4 is a critical point of the function f. A critical point of the function f. Okay. Right. Now we need to show that this point is really will give us the minimum value of the function f. What should we do? فنجيبنا 0.44 المفروض ان يعني you should get minimum يعني for sure يعني but we need to show it how to do that. لا تنسوا شباب الفانكشن هذا هو الفانكشن هذا هو الفانكشن. This is the function. How to show that the 0.44 is really a minimum of this function? Yes, Abdullah?
Substitute in the original equation.
طيب, if I get 6 and 9, I substitute the equation, then what?
It's the minimum.
No, if I get a numbers different from 4, 4. If I get two numbers, let's say, يعني 4, 4 and another number.
You talk about z.
Forget about z. Let's you found a point, okay? Can I use a test on this point that will tell me it is really a minimum or maximum
yes.
of this function? What
yes.
is that?
D equal f.
This is what I'm looking for. This is what I'm looking for. So now, in order to calculate D, I need to find fxx. Fxx يا شباب is equal 4. Fyy is equal from here also equals 4. Fxy equals 2. Okay. So now D equals. Now here, of course, شباب, I have to solve the point, but you have constant. So we have 16 minus 4, which becomes 12. This is greater than 0. And we look for the sign of xxx, which is 4 greater than 0. So you have D, the discriminant, greater than 0, and if xx is greater than 0, so f has a minimum, local minimum value at the point 4, 4. At the point 4, 4 يا شباب. Okay. طيب. Now, what is next? There is a quiz يا شباب, attendance quiz. Please do it now. There is a attendance quiz. Please go do it now. So we said f has a local minimum on this, but it turns out this is the only minimum that the function has it. So we can upgrade it to say that it is absolute minimum. Okay, this absolute minimum. Okay, so f has an absolute minimum at 4, 4. طيب. Now, so x equal 4, y equals 4. This implies that, I mean, we did the calculation for the z, okay, which is here. Z equals 4, okay. So the numbers, so the desired numbers are 4, 4, 4, whose the sum is 12, and the square of their sums is the lowest as you can, is the least as you can. And the least, of course, because if this case would be equal to 4 squares plus 4 squares plus 4 squares, 16 plus 16 plus 16 يا شباب, 32, and then 48. Okay, 48. This is the least thing you can do in the squares. Okay. Any question here, شباب? Maybe some of you will think this way. You say, okay, I found a point. خلاص, I'm done. I'm done. I found the point, the critical point. This critical point should give me the minimum automatically. In general, you have to check, شباب, because you don't know. Maybe you will get some certain point, and then when you do the test, instead of minimum, you will get maximum. You get the opposite what you are looking for. So that means maybe you have to check the signs or whatever here. Okay. So just do this discriminant test to make sure that really what you obtain is the desired one. It is what you're looking for. Okay. So this is for first optimization problem. The next optimization problem, it says find the points on the cone that are closest to the point 420. Okay. In fact, this example, it can be solved in a different way, which use the ideas of the coming section. But for now, let's stick with what we have here. Especially, Ghana exam is up to the end of this material. طيب يا شباب, how to find the points on the cone that are closest to the point? When I say closest يا شباب, closest, is it maximum or minimum? Abdullah.
Minimum.
Minimum. We are talking about minimum. Okay.
Yes.
So we are looking for minimum. Minimum of what?
The distance between them.
Minimum of the distance. Okay. But what is the distance? What is the formula of the distance, Shabab? We are talking about 3 dimensions. So we have x, y, z, and the other point is he gave you 420. طبعا هذا point on the surface. Huh? This z يا شباب, the z component is exactly let's say square root of x squared plus y squared, right? Plus or minus. You know exactly what is z, right? But let's say this is x, y, z on the surface and this point. طيب, what is the distance between these two? D, let's call it D, for example, equals, Shab, what is the formula for the distance? The Rakan is only one who is participating. I'm looking for others.
The difference between the x's square.
Bismillah, Bismillah.
X minus 4 square
plus
y minus 2 square
plus
z square.
Z square. Okay, so this is
We
what
can
have.
take the we can multiply.
We can
Yes.
take this. Okay, keep in mind this is the cone that we are looking for. Okay, طيب خلاص, so that's what we need. طيب, now Z square يا شباب, it is this. Okay, it is this. So this implies that D square equal. طبعا you can open this, x square minus 8x plus 16 plus 2, no sorry, y square minus 4y plus 4 plus now z square. I'm gonna substitute what I have here, which is x square plus y square. So this implies that d square equal 2x square plus 2y square. Okay, and then we're gonna have minus 8x minus 4y plus 16 and 4, so we have 12. طبعا يا شباب, you can say square root if you want. You can say square root, but then we're gonna struggle with the derivatives of the square root. So it's better to keep it d square. Huh? يعني call this f. Call this f. Huh? Instead of d square, let's call this f. F of x. This is our function that we are looking for the minimum. For the minimum. Okay, for the minimum of this function. How to find the minimum of this function? Okay, we have to find. Okay, so this is f of x and y. We have to find the critical points. How to find the critical points? Well, the same way. Fx and fy. So here you have 4x minus 8, and here you have 4y minus 4. This is equal 0. This is equal to 0. This is piece of cake. So we have x equal 2. From here you have y equals 1. So now you have 1 point that serves as critical point. طيب يا شباب, how to check the d? Well, we keep up, okay, for the second derivative. So this is the d, fxx يا شباب, which is equal to 4, fyy which is equal 4, fxy يا شباب كم يعطينا؟ 0. فمعناته d equal 16 greater than 0 و fxx greater than 0. فصار البوينت هذا f has minimum at 2 and 1. فصار ايش what is the closest what are the points? Okay, so if x equal to y equal 1, then z square equal, now remember this point 2 1, it should be on the cone. It should be on the cone, so I have to substitute here. So you have 4 plus 1, which is 5. This implies that z equal plus or minus the square root of 5, because you have two values. So the points on the cone are, okay, 2 1 the square root of 5 and 2 1 minus the square root of 5, because you have 2 points on this cone, right? 2 points of the cone that are closest to the point 4 2 1 0. Okay, and done. Any question here, Shiban? Right. So we have it here. Right. The last question that we want to go through. Find the dimension of the box with volume 1000 centimeter cube and that has minimal surface area. Minimal surface area. Okay. Right. How are we gonna solve this way, Shiva? How are we gonna solve it this way? شباب يلا. Find the dimensions of the box with volume 1000 centimeter cube that has minimal surface area.
ممكن استخدم قانون surface area.
طيب يلا بسم الله. Let's call it F equals. طيب let's imagine the box. Huh? Let's imagine the box. So let's say I'm gonna just sketch the box like this. Okay. Okay, this is the box, and let's give the dimensions name. So this is x, this is y, and the height, let's call it z. Okay, x y z. Box طبعا not necessarily squares, but you're gonna have rectangles. Okay. طيب, this is a how. So what is the surface area? How many faces you have for this box? كم وجه له يا شباب؟ How many surface faces?
6.
Yeah. عبد الله حسن 6. This is what you want to say. طيب, وكل face ترى rectangle. فكيف how to calculate the surface area? What is the area of the bottom here? This bottom rectangle. Yes, Abdullah, Faisal.
XY.
XY. How many of the similar face to this one? You have the top also, right? So you have 2 of them.
Yes.
So then you're gonna say 2xy plus. Then you have this, for example, this face in the front. This is the dimension here x, and here it's z. Okay, z. So we're gonna say x times z. You have this face, and you have the one behind. So we have 2xz plus, and then you have this yz. The area of this face is y times z. You have 1, and you have another one here behind. So we have 2yz. So this is the surface area. This is the surface area of this box. Of course, in the question, you see that he asks you for the minimal surface area. So we are looking for the minimum of this function, giving that the volume should be 1000. So what is the volume, Shabab? What is the volume of this box?
The multiplication of all of them.
أيوة, اللي هو area of the base. We can think of it as a cylinder. Area of the base times height. What is the height? Z. And we need this to be equal to 1000. So we have this, what we call constraint, and this is the function A. Okay, Shabab. Now, how to do this? First of all, I have a variable z. I can eliminate this variable by substituting this guy, right? So this implies that z equal 1000 over xy. So I can take this guy and substitute here. Substitute in the function. Yeah. Okay. So now f equals 2xy. Now when I take this shabab z and I put 1000, it becomes plus 2000 over x will go, so it becomes y plus, when I take this z and I put 1000, so it becomes 2000 over x. Now this is my function f. Okay, my function f. So let me just maximize it, and this is a function f. Now this is a function of 2 variables, so I can find the critical points right away. Fx equal and Fy. What is Fx, Shabab? Derivative with respect to x, so you have 2y. Derivative with respect to x, this will be 0. What is derivative of this with respect to x, Shabab? Yes, Abdurrahman?
Minus 2000 over x square.
Over x square, very good. Here, derivative with respect to y, so you have 2x minus 2000 over y square. I need these to be equal to 0. Okay, I need these to be equal to 0. So how to solve this system of equations? كيف نحل هذه ال 2 equations يا شباب مع بعض؟ How we can solve it? Any ideas? Yes, Walid?
Make one variable in terms of the other.
Very good. So for example, from here, this is equation 1 and 2. So I can use a different color. So this from here, y equals, you divide by 2 and all of these guys, so we have 1000 over x squared, right? So substitute this guy here. Okay. So substitute y equal 1000 over x squared in equation 2. So what you will have, طبعا in equation 2 يا شباب هذه you can write it as x minus 1000 over y squared equal to 0. You can divide by 2 here, right? You can divide by 2, so you have here. Now let's plug this guy here, okay? This implies that x minus 1000 over. Now keep in mind you are squaring this, so this is 1000 square, and this the x square here down, it becomes x to the power 4, so I plug it up this way. Okay, now this will become x minus 1000. We cancel with 1000, so you have x to the power 4 over 1000 equal to 0. So now you have equation in x. You can take x as a common factor, so it becomes 1 minus x cubed over 1000 equal to 0. Okay. Now here you have two situations, because you have a product, this times this. Either this will be equal to 0, or x cubed becomes 1000, which means that x equals 10. Can we accept this, Shabab? What is x
No.
in the original case?
No.
Yeah. Why now, Shabab?
No, we cannot.
Because length of the box, right? So we cannot accept length 0. So this will be rejected. We take this. Okay, we take this. Type. So if x equals 10, then what is y, Shabab? From here, right? Looking here, this is a relation between x and y. So y equal 1000 over 10 square, which becomes y equals 1000 over 100, also 10. طيب والz يا شباب؟ This is it. Okay, this is it. So z equals 1000 over 100 also, so this implies that z equals 10. طيب, so now you have the dimensions. Now how to check that this really give us the minimum, يا شباب? This is a function f. This is the fx, fy. How to check really this will give us the minimum? To check whether the critical point 10 gives the minimum of f. We do the discriminant way, so let's check the point. Sorry about this. Check the point يا شباب. Check the d. fxx يا شباب يساوي ايش يا شباب؟ what is fxxx? What is the derivative of this one يا شباب؟ يلا. Anyone? $4,000. ايوه.
x أس 3
x cube ممتاز. وعندنا fyy نفس الشيء.
The same.
ايوه similar way. وطبعا fxy, when you differentiate this with respect to y, you will get only 2. Okay, so this implies that fxx 10 when you substitute 10 شباب becomes 1000, so it becomes 4. And the same way fyy, when you substitute 10 you get 4. So d is equal this times this 16 minus this square 4, so you get 12 greater than 0. And clearly from here fxx is greater than 0, so f has minimum, actually absolute minimum as 10. So the final answer, we can say the dimensions are 10, 10, 10, 10. Tell me. Okay. واضح يا شباب؟ If you want to make a box, with minimum surface area, why we care about in industry يا شباب? Why we care about the surface area to be minimum? I'm talking about industrial perspective of view. Why we think of this we need to be minimum يعني ليش يحتاجوا minimum؟ اوكي يس خلينا ناخذ مثلا وليد، تفضل يا وليد. What do you think؟
تفضل دكتور. عشان اتوقع ان يوفرون المواد.
Yeah, so in manufacturing this box, they want to look it for the minimum. This is one of the things. Included many things. يعني, for example, they need to, if they want to put the stickers here, it will be the minimum thing they can do. It won't cost much for them. Okay, so this is one of the things that we need to care about. So that's why you can solve such a optimization problem, and you can give them the ideal box for them. 10, 10, 10. Okay. Right. So this is for questions of optimization problems. I just selected 3 optimization problems. And I did not include any question from all the exams for these because I found them straightforward what we are doing. Really straightforward what we are doing. So I didn't include any of them. Okay. Is there any question in this section, Shabab? Okay. I think it's clear, but it requires some algebraic calculations to handle this. طيب يا شباب. So we are done with these. Okay. Now we move to this section. But keep in mind يا شباب that where are you? Yeah. So keep in mind that the material of the coming online assessment is at the end of section 14.7. Okay. This section, which we're gonna come to this, it's not included. The 14.8 is not included in the coming online assessment. Okay. Someone who has raised his hand, Muhammad, I think. Or is there any question? ولا خلاص. طيب. Okay. So now this is a section 14.8, which is a Lagrange multipliers. Lagrange is the name of a scientist, a mathematician, and also he works in physics and mechanical engineer or many fields. يعني. That time, the 18th, 19th century, you'll find one scientist works everywhere. يعني. Okay. So this Lagrange, he has a great contributions in mathematics. He made this way or this method which we call the Lagrange multipliers. The idea is this, Shabab, that is to find the extreme values, which mean by maximum minimum, of a general function f(x) and y and z, either 3 variables or 2 variables, but subject to a certain constraint or a certain condition of the form gx, y, z equal k, or the constraint will be 2 variable functions gx, y equal k. So it is a question of finding maximum and minimum, Shabab. But what is different, what we are dealing in this section, different from the previous section, that we want to find the maximum minimum values of a function f, but not just like that. No, he will give me a constraint. He said, no, I need the minimum maximum and satisfy this also, another condition to that. Now, in the previous section, Shabab, in 14.7, we found the maximum minimum values of function on the entire domain. This is what we did. Or we find the maximum minimum values of function in a closed set or a closed domain. Okay, a closed bounded set. This is what we did. Or sometimes we made it a condition, like what we did in the optimization problems. But for those particular problems where you find the maximum minimum functions of maximum minimum value of function f with a certain constraint, we can use another method, which is this one, what we call Lagrange multipliers. Okay. So you can use this, Shabab. If you look at the questions that we solved just now, the optimization problem, we can solve using this, Lagrange multipliers. And even one of the questions in the previous section, you can solve it using this one, using Lagrange multipliers. Okay? So let's understand this method. Yeah. Let's understand this method. That's I prepare some GeoGebra, the software. So let me prepare it for now. I don't want to open it and it will happen like last time. It freezes and so on. So I said I want to open it fresh. Bismillah. Open the file. Lagrange. Okay. So طيب شباب. Let me share what I'm seeing to you. طيب. يعني understand the idea of the Lagrange. Where did it come from? But of course in the computation we do something and we get it a formula and we're gonna go with it. Yeah. Okay. So let's assume you have a certain surface, surface like this, a function of two variables. Okay, a function of two variables. We're gonna think of a function of two variables, and we're gonna the three variables will be similar way. Okay, this is a function of two variables. Okay, what is the equation of this sphere? Well, it is given here. X squared plus y equal 4.125. Yeah. Sorry, x squared plus y minus 5. This is the equation. Huh? This is the equation of this surface. Right? Right. Now we learned something. Yeah, and this surface, Shabab, someone will say, no, if I ask to find the maximum minimum values of this, what you will do, you will find the critical points, do the D and everything. But what if I said, no, I need the maximum minimum values only over this circle? You see here, Shabab, this circle, which is the equation x squared plus y squared equal 4. The circle of radius 2. Okay? Circle of radius 2. I said, no, I need a point where the xy coordinates satisfy this circle, and the function, the red function, the surface, has the maximum minimum values over this circle. Okay? Has the maximum minimum values over this circle. Okay? So, what you will do, you will project the circle on the sphere, on the surface, but this idea is not clear to us. But what we'll do, we'll project the surface on the circle. How? Do you remember the level surface, Shabab? Where you make the function equal constant. This function x squared plus y minus 5, you make it equal to constant. When we make the surface, it's the same. So let me do it this way. Do you see this this blue, this one? This is the level surface that we learned. What we try to is to make z equal any constant, and then we take this intersection point. Okay, if you look here, and project on the xy plane. And project the xy plane. So this is in the left here, Shabab. This is the projection, the level surface on the xy plane. And every time when I make a projection, I make a copy. Okay, so I can restart again. So I make a copy, up, down, up, down, up, down. Sure, huh? And I make it equal constant. I make it copy up and down. Okay. So let me okay. Let me do it this way. Okay. كان عندي equation السيرفس زي كده شباب. F Z equal x square plus y minus 5 اللي هي اعتبرها يا شباب f of x y equal x square plus y minus 5. اوكي. ايش هو الليفل كيرف او ليفل كيرف سوري اسف ليفل سيرفيس. ايش نسوي يا شباب؟ نقول x square plus y minus 5 يساوي constant let's call it c. اوكي. فايش اللي يصير يا شباب؟ هذا equation لو نجي نرسمها ايش يطلع لنا يا شباب؟ What does it represent in the xy plane?
Parabola.
Parabolas, very good. Parabolas. كل ما غيرت السي يا شباب كل ما اعطتك بارابولا جديده. اوكي؟ فهذه equals c. طب لاحظوا معي يا شباب fxy equals c ها fxy equals c. اوكي طيب نحن لما نيجي نقول يا شباب when we say the maximum value of f كيف نكتب الماكسيمم فاليو يا شباب؟ نقول f x مثلا a b equal some number c. So c prime or whatever, right? Let's say 10. So this function, it could obtain the maximum minimum values by coincidence. There is one of the c's, right? One of the c's, I put it here. This is the c. It could be the maximum value of the function or the minimum value of the function here, right? So in the xy plane, there was a circle. This is the constraint. هذا هو الشرط حقنا. قال لك لا أنا أبغى بس على هذا السيركل. of radius 2. The circle, the equation of the circle is x squared plus y squared equals 4. Okay? طيب. What happened to the parabolas? Well, I put c equals 0. I project on the xy plane as in the program, as you saw in the program, which is this one. Okay? كل ما أخذ constant, this is the a constant. I project it on the circle. Okay? I project on the circle. لكن في حاجة مهمة يا شباب ننتبه لها. لما أتقاطع مع السيركل يا شباب, when the parabola intersect with the circle, I will find the minimum maximum values on the intersection point, right? On the intersection point between the circle and this guy, right? On this this sphere, okay, or the level curve, okay. So every time I make copy, I will intersect with this one, okay. Which one I'm looking for? Look at here يا شباب. Look at here. هذا أقل C ممكن نوصل لها اللي هو ال right hand side. When I go down, I am outside of the circle, right? So I have to exclude those. تمام؟ I have to exclude those. ولما أزيد في الC يا شباب, when I increase the Z a little bit, I touch, okay? I touch the circle. I barely touch the circle here, okay? I barely touch the circle. So if I go back here, if you remember, there is one level surface or level curve, sorry, barely touch this one. The f x y equal some c, c tilde, and the c actually we found it to be. We can come back to that software. اللي هو a equal negative 7, a equal negative 7. So this will be equal to okay, so yes, so this will be equal to negative 7 here, right? طيب, and then what يا شباب? Okay, what do you think of this level surface يا شباب? If I go back here. go back here يا شباب. هذا هو الليفل اقل شيء يا شباب. هل هذا يمكن يعطيني مينيمم يا شباب؟ لو ازيد when I increase this level surface, when I go up, اكيد هذا السي حتكون اكبر صح؟ because when you increase C you go up, when you decrease C you go down. لكن the minimum thing that you will intersect the circle is this one. So this is the minimum. This is the minimum value. And of course you will go every time you increase the C until you hit one like this. There is one goes like this, and there is one big one, and let's put it in black, goes like this. Barely touch here. This is the highest one. Let's call it K, for example. Okay? ونقدر نجيبها يا شباب. We can find it, we can, يعني because I'm using software, we can go a little bit up. هذه شوف هذا هو level surface, هذا هو لما A equal negative 3, but I can go a little bit up and barely I'm touching these when A equal negative 0.75 اللي هو touching these 2 points. So let me just put these 2 points, these intersection points. طيب قدرنا نعرف الماكسيمم مينيمم شباب. Is there any questions so far? Because I don't want to go deeper and then it'll be like I'm talking to myself. Okay? هذا هو الماكسيمم والمينيمم هذا. Okay? أقل شيء the least that it can done. Oh no, not this one actually. Not this one, not this one, this one. Yeah, this one. Okay, this is the least minimum value, and this is the maximum value. طبعا تلاحظون يا شباب when I increase the constant after the function, the level circle will be outside of the circle, which I need to exclude them. Okay, so yeah. So I have this. Now let's look at this. Let's look at this graph. Okay. Let's look at this graph and let's go back to the paper here. Okay. This is what Lagrange found. This is what Lagrange said. Okay. So let me make one clear picture. Okay. One big picture like this. Okay. So this is the circle. And we said that, well, there is a level surface. Okay. Let's do it in black like this. هذا اللي عطتنا الماكسيمم. Okay, something like this. So it will intersect, barely will touch the circle at 2 points. Okay. Now Lagrange, what he said, okay, of course I'm using software, that's why I'm able to find it. But of course we want to find it without using software, and we are talking about Lagrange. He lived in the 19th century, so he didn't have any software, computers, or of these guys. So he said this. He said, well, I observed something. If I want to find the tangent line of this circle at this point, it will be this, right? This is the tangent line, right? The red one. If I want to find the tangent line at this point, it will be something like this, right? It's a bit vertical. طيب, if I want to find the tangent line of this parabola at this point, what do you think? إذا بجيب التانجنت لاين يا شباب للبارابولا at this point, this intersection, what do you think? What will be the tangent line? How does it look like? It will be the same tangent line that you'll find it by the circle at this point. The circle and the parabola, they share the same tangent line at that point. And the same thing here. But also, he said, okay, now in order to find the tangent line, I have to find the derivative, right? Or the gradient. So what is the normal vector for this circle? Okay, for this circle, this is the normal vector. So let's call it how to find the normal vector of this circle, شباب. هذا السيركل اعتبرها كفانكشن g of x and y equals 0, let's say, for example. Huh? So how to find the normal vector of this circle? What is the normal vector, شباب?
The gradient.
Exactly.
The gradient.
So this is the gradient of g. This is a vector, gradient of g. ممتاز. طيب. Now assume this parabola is a function of f of x and y. Okay, equals 0, let's say. Huh? So what is the normal vector of this function? It will be this. Let's say, for example, this one. It will be like this. Okay, because they share the same tangent line. If you notice the normal vectors, they are in the same direction, but with different magnitudes. Similar situation going on here. If you calculate the normal vector, the gradient of g, you will find it this way, and f, it will be either bigger or smaller in magnitude, but they share the same direction. Okay, at this point and this point here. So since these normal vectors are parallel, what you can say when we say parallel, شباب, means that the gradient of f is equal a constant multiple of the other. The constant, let's call it lambda, of G. This is what means parallel يا شباب. لما نقول vector parallel to vector معناته one of the vectors is just equal constant multiple of the other. It could be half length of this one, it could be double length of G, it could be the opposite direction. It's fine here. Okay, so this is what you have. Now this one, this equation, it is the core idea of the Lagrange multiplier method, and lambda is called Lagrange multiplier. Lagrange multiplier. Okay. Any question here, Shabab? The same idea goes here, Shabab. Can you find the minimum here? This is the tangent line like this. Let's say, for example, the normal vector is going this direction, the gradient of G. Then if, let's say, maybe longer or smaller, like this. When you calculate the normal vector, it happens they share the same direction. Okay, so this is what we do. So next time when we want to find the maximum minimum, Shabab, we solve this equation. We solve this. The gradient of f equal constant lambda equal gradient of G. So this is the core idea of Lagrange method. Right. Now let's yeah. So this is the software. Now in the software we can find the maximum minimum values. You can find it, and I can give the file to you, so you can tell where is the point. So this is the point. He gave me the points here. I can tell what is the maximum at this point. And if I go a little bit, this is one point also, a candidate for maximum minimum values. But if you go a little bit up, you will find another 2 points actually. They will give you the maximum value. The maximum value over this circle, over this circle. So we can find that. But let's say I don't have the software. I want to find it by hand. Okay, I want to find it by hand, and of course by the software I have to do trials until I get it this way. So now, in one constraint, the method summarizes it this way. So to find the maximum minimum values of f of x and y subject to the constraint, this function, by the way, Shabab, you can deal it with 3 variables or 2 variables function, all works. Assuming that these extreme values exist and the gradient should not be equal to 0 on the surface gxy equal k or gxy equal k. The first step is, Shabab, solve this equation. Find the values of x, y, z, and lambda such that you satisfy these 2 equations. The gradient f equal lambda gradient g and g equal k. Of course, Shabab, we have talked about 2 variables. Forget about them. خلاص عندك x, y, lambda. So you have to solve this. Of course, when you solve x, y, z, you get certain points. The number lambda is called Lagrange multiplier. This is what we talked about. And then what we do, evaluate the function f at all of these points. Evaluate on these points that results in step A. The largest of these values is the maximum value of f. The smallest is the minimum value of f. You deal it like the case of, if you remember, the absolute maximum minimum on the closed bounded domain, like this. But this is easier. Even this Lagrange is easier. Now, what we do, we solve these 2 equations and we substitute on the value function at the points that result from these calculations, and you are done. Okay? Right. So now, let's solve this. This is exactly what I did in the software. I put x squared plus y minus 5, and the circle is x squared plus y squared equals 1. And we want to find the extreme values of this function that are on this circle. يعني الاكس واي يا شباب لازم يكونوا في هذا السيركل. لازم يكونوا في هذا السيركل. It's different when I say find the extreme values of function. I just say that like this without mentioning the circle. It is a different way. Find the critical points and all this stuff. But now when I say no, I need the extreme values of function on this circle, the situation is different now. Okay. So what we do, Ishbab, now let me write this. So we want to extreme values of f x or y, which is equal x squared plus y minus 5 on the circle x squared plus y squared equals 4. Okay, so this is what we do. Now we have to identify who is f and who is g. لازم نعرف مين ال f وال g. ال f هذه يا شباب. خلاص اعطاك اليوم. طيب let gxy يساوي who is g يا شباب؟
circle
which shall I write?
x square plus y square.
Okay. Some people they put -4. Okay, يعني we bring 4 here, so we say -4. Some people they don't put 4, and you will find it doesn't make change. The constant doesn't make change. Okay, why? Because when you calculate the gradient. Now the next step, shabab, we want to do this gradient f equal lambda gradient g. Okay, so what is gradient f, ya shabab? What is gradient f? Now you have exam shabab on Wednesday, so you should know what is gradient f. Yes. البارشل اللي هو ال fx equals gradient f derivative f with respect to x, which is 2, comma derivative f with respect to y, which is 1. Okay. طيب gradient g, derivative g with respect to x, derivative g with respect to y equals. Now derivative g with respect to x is 2x, derivative is 2y. You see now, shabab, the constant. If you did put it, there is no effect on the calculation of this one. Okay. طيب يا شباب. Now we want to solve for x, y, and lambda. Yani we have 3 unknowns such that, okay, gradient of f equal lambda gradient of g, and g of x and y equal k or 0 or whatever you can say this way. This implies that. طيب يا شباب، الآن عندكم هذا الفيكتور. Okay, اللي هو هذا. I will do it once, but of course later you will see that I'm gonna straightforward do something else. Okay. Now I multiply lambda to this one, so we have 2 lambda x comma 2 lambda y, and then this constraint, which is x squared plus y squared equals 4. طيب which implies that لما نقول فيكتور يساوي فيكتور يا شباب، لما اقول فيكتور يساوي فيكتور ايش معناتها؟
معناها بارت الاكس يساوي الاكس وبارت الواي يساوي الواي.
ايوه هذا هو. اوكي، this يساوي this و this equals this. سوري y و x square plus y square equals. So from here يا شباب، from here when I say this, it means that derivative f with respect to x is equal lambda derivative g with respect to x. Derivative f with respect to y is equal lambda g with derivative with respect to y, and of course gxy equals k. هذا هو. هذا اختصار للgradient. If you are talking about, of course, 2 variables. If you're talking about 3 variables, you're going to have a third equation, f with respect to z equal lambda g with respect to z. Okay. Fourth equation, another one. But talking about 2 variables, we're going to have it. This is exactly what we have. So later, when I write this, I directly jump to this. Okay, jump to this, which is exactly this one. طيب يا شباب. Now let's solve these equations here. Let's call this equation 1. Let's call this equation 2. Let's call this equation 3. طيب, from equation 1. طيب, bring this guy to other side. 2x minus 2 lambda x equal to 0. Take x as a common, 2x as a common factor. It remains 1 minus lambda equal to 0. How many cases I have here? I have either x equals 0 or what يا شباب? Or lambda equals to 1. طلع حالتين يا شباب. Okay, and I have to study each case. If there is something I have to exclude, I have to exclude. If something I have to include, I have to include. So I take everything we have. Okay. طيب يا شباب. Now I take x equals 0 and I continue, and then take lambda equal 1 and see what I will get. But before I go there, please do the attendance quiz now. Please go do the attendance quiz now. if x is equal to 0 يا شباب, then can I get y? Because I'm looking for y يا شباب, the points. هل اقدر اجيب الواي يا شباب؟
معدل رقم 3.
Yeah, then from equation 3, y square is equal 4, so this implies that y equal plus or minus 2. So the points, we have 0, 2, and 0, negative 2. خلاص عندي هذا البوينتس. Okay, let me put it this way. هذا البوينتس اللي راح اعوض في الفانكشن عشان اعرف انه بيعطيني ماكسيموم مينيموم. اوكي, طيب عندنا 2 candidates مرشحين, 2 candidates, بس هذا اللي جاب لي x equal 0. حلو. طيب لازم ناخذ هذا الكيس. The case, okay, when lambda equals to 1. طيب لما lambda equals to 1 ارجع, I go back to our system. هذه 1 خلاص, we are done with it. Now if you look at 2 يا شباب, what you will have, from 2 we get, what we get يا شباب, y equals
half.
half. طيب now I have y. How to find x? Because x is remain. By the way يا شباب, here I didn't need to find lambda because I'm caring about x and y. That's it. I'm caring about the point. But here, if lambda equal 1, I found y, but I need to find x. How to find x يا شباب?
From g of x.
From 3, we get x squared plus 1 over 4 equal 4. This implies that x squared equal 4 minus 1 over 4. طبعا هنا 16, 15 over 4. This implies x equal to the square root of 15 over 4, or x equal negative square root of over 4. So the point here is square root of 15 over 4 and half, or minus the square root of 15 over 4 and half. Okay, so how many points I have so far يا شباب? عندي 4 points. I have 4 points. I have to check. وخلاص, now I did 1, 2, 3, 4. Now I have 4 points. What I will do, I substitute. Okay, so what left is substituting. Substitute these points on the function f, or in the function f. طيب الآن نجي أول واحدة, f of 0 and 2 إيش يساوي؟ اللي هو البوينت رقم 1, هذا هو. وخلينا نتذكر الاف يا شباب. الاف ايش هي؟ اللي هي هذه, اللي هي هذه x square plus y equal 4, فيعطينا 0 plus 2 minus 5 أعطاني نيجاتيف 3. طيب هذا البوينت رقم 1. بوينت رقم 2 اللي كان 0 نيجاتيف 2, اللي جبناها قبل شوية, هذا هو 0 نيجاتيف 2. اوكي, فايش يصير يا شباب عندي؟ 0 نيجاتيف 2 نيجاتيف 5 أعطاني نيجاتيف 7. حلو. نمبر 3, البوينت الثالثة يا شباب اللي هي هذه حقت السكوير روت. اوكي, f square root of 15 over 4 comma 1 over 2 equals. طيب الفانكشن مرة ثانية يا شباب هذه x square, فلما تربع هذه يا شباب ايش يصير عندي؟ حيطلع لي automatically this one, right? And then plus half minus 5. Okay, what is which is equal to now this is over 5, now 15 plus 2 minus 12, right? So it will be minus 3 over 4. Okay, طيب number 4, f of negative of this guy will give me the same number, right? Will give me the same number. No, there is a square, there is a square. A square, so it doesn't matter. طيب يا شباب, وين الماكسيمم وين المينيمم؟ Where is the maximum? Where is the maximum? Is it -3 or -7 or these guys?
نيجاتيف minus 3 over 4.
هذا الماكسيمم. This is maximum. والمينيمم -3, right?
No, -7.
-7. So this is the minimum value. So the function will have minimum value at the point 0 and -2. It has a maximum value at these 2 points. And keep it, and also these points 0, -2, and this satisfy the circle. يعني these points are on the circle. Okay. Now we said the minimum is at the point 0, -2 يا شباب. If you remember when you go back to the software, no need the software actually, because I'm afraid the software will be. هذا هو 0 -2. هذا هو البوينت. هذا اللي اعطتنا المينيمم. نحن قبل شوي قلنا هذا يعطينا المينيمم يعني ها. وها شوف -7 لانه في البرنامج اعطاني -7 which I found it here. Okay. And the maximum was this. And there are 2 points of intersection. تفضل هذا هم ال 2 points. هذا first quadrant وهذه في second quadrant. Okay. وهذا 2 points. If you go to the software, we will find that the K, the constant is this. Okay, is this. I don't know if the software will fail me or, yeah, it's a hanging. So you can, the software I can upload the file and you can check it. واضح يا شباب؟ Now you see the Lagrange, he found this way in the 18th by gradient, and he said, okay, I can find it the maximum minimum. And you see how this method is very effective, very useful in obtaining the maximum minimum value. Okay, شباب. So this is one example. Inshallah, in the coming lecture, we're gonna do more examples on this regard, on this Lagrange multiplier method. طيب. Any question يا شباب in this section? Okay, I should stop here.